Let's say that I'm giving you a quick little exercise. You're project manager for manufacturer. Someone's coming in to install a couple of columns for you. Maybe add some bracing. Let's say that you're adding some new equipment, okay? And this new equipment has a lot of vibration. Happens all the time in manufacturing. We're rigging big stuff. We've got to hold it in place, right? In fact, one of the common things that happens is that large equipment is not always mounted to the ground. What do we do sometimes when we know we got a lot of vibration on heavy equipment? Ever dealt with this before? Well, they'll do that, but sometimes they actually want to have a floating connection system. So what they'll actually do is they might set the equipment on a big W-beam. So here's heavy equipment mounted on big W-beam. You also see this done a lot with HVAC equipment, because sometimes we want to actually deal with the vibrations so it doesn't actually get to the floor system, especially if we're on a second floor. So we can actually add in isolator pads or vibration pads, big giant springs, and then mount that to the concrete. Okay? So not too uncommon situation in terms of large equipment installation. But let's say that we're going to do that scenario, and we're going to focus in on this area right here, the connection between the isolators and the W-beam that the actual equipment is resting on. So there's our scenario. So here's the W-beam. How can I tell it's a W-beam from this side view, by the way? That's true. That is true. It could be C, it could be W, because these edges aren't what line type. If they were hidden, they would represent what kind of situation? Probably a steel tube, okay? Because you'd be seeing the inside walls. Since they're not hidden lines, that means I'm seeing them, so they could be C-channel or W-beam. It's absolutely true. Technically, it could be like an I-beam as well. The flange width is the controller. But anyway, let's say we're going to fabricate this setup for our big equipment that's coming in. We're going to do it for them. And we know that we're going to attach we're going to use some kind of C-channel piece to attach our big W-beam to our springs down below. So, real quickly, what do we know we have to do between this W-beam and this C-channel to make this thing work? Got to weld it, right? Okay, what would you call out right here? What would you say? What would you suggest? Okay. So, we can throw a fillet weld. I'll start off with a fillet weld to this side, which means it's going to weld along this plane, right? Now, we might suggest an all-around, nothing wrong with that, because we're going to weld around there, and the back side. And an argument can be made that you might need to do the detail that way, and it's implied that it's on the back side of this part, not on this zone. Common sense factors in because there's nothing to weld here, right? So we can actually put a double flag in conjunction with the all-around. Now, technically, is this a shop weld or a field weld? Yeah, it's technically you're outside your fabrication place, so you call it field. Of course, somebody's be like, well, we're indoors in the shop, so you can call it either way. But, you know, if you went with a flag or didn't go with a flag, it wouldn't matter too much. So let's just say, for example, we're going to use a 3/8 weld. Now, do I need to include a length and pitch right here for this? I don't. Why not? Well, it's continuous. It's all the way around the whole thing. Okay, so that works out. That wasn't too hard. But let's change it up a little bit. Let's add a new scenario to make it a little bit more challenging. Let's say, for example, that I'm going to add a stiffener plate. Let's say that our C-channel needs some reinforcement. Now, what I'm about to do would not really be done in real life, but we're going to do it anyway. I'm going to take a really thick plate, and I'm going to mount it. I'm going to sandwich it to the back of the C-channel. So there's your C-channel. Here's your thick plate. But the thick plate is the exact same length as the C-channel, which means we don't get to use any fillets in this zone right here. The edges, this edge that you see and this edge you see are flushed across the surface. So with me so far? So in this case, I need to weld this plate to the W-beam. So I got to put a weld right here. What would you suggest? Fillet will work just fine. And can I technically do both sides? Not really, because there's no way I can get to this with a fillet weld. So I'm looking at a one side only. And we're going to assume it's continuous, and we'll just assume the size is about the same. So that's about all the detail would be there. But how am I going to connect this big thick plate to my C-channel where this surface and this surface are flush? What would you suggest? Well, what? Well, it's not in this case it's not a butt joint. It's close. What kind of joint is it? No. It's an edge joint, right? Because you've got, if these two surfaces are flush, it means that your C-channel and your plate look like that, right? So we need to figure out a weld that would work well. What would be a good weld that can work with an edge joint situation? Technically you call it an edge weld, but what a V-groove would be probably the easiest and fastest. So I'm just going to go through a symbol here, move it over there, V-groove, this side. We'll just set the, I can probably go as deep as I want to go, because I can keep going into the part, but a 3/8 will be fine. Now technically we want to do both sides, might as well. We could actually do that in this case, because we can come from the other side of the part, all the way on the back side, and V-groove there too. Can't do an all around, can we? We could do one side we could do down here though, couldn't we? Because it's a flush all the way around. Well, what you're looking at right here, this side is the side that we see, this is the side we can't see, this is down from below. So what I'm doing when I'm implying this, I'm cutting into the thing from the other side. It's not a very good graphic, I admit.
So you don't weld it together and then weld it to the building beam?
Well, you could. Theoretically, you'd be definitely better to do that. We just started off winging it, so we just went through it. But yeah, you're actually right. You would want to weld it together in practicality, put together. So again, why I say we wouldn't actually do this in real life, once again. But it's a good example. Now, let's just say for kicks and giggles that I'm also going to do, let's say, attach some kind, we're going to have some kind of piece of angle, all right? And the angle is coming out at us. With me so far? So like from the side of all this nonsense I've got going on, there's your W-beam, here's your C-channel and plate combo underneath, and here's your angle sticking out. With me so far? Okay. Now, I need to attach this angle to this. What we're going to do is we're going to use this piece of angle as some kind of pinpoint to actually have like a cable attached to something. And so there's going to be a hole in this angle. But for right now, we need to weld it onto the W-beam. That's what it's going to do, is it's going to support some kind of tension cable, etc. So I can't get to this surface right here to weld. It's concealed by the flange of the W-beam. So that surface is out. So what would you recommend in terms of me welding this angle to this W-beam? A fillet weld where? I'll give you some options. You got side 1, 2, and 3. I can get all 3 of them, right? Because I've got enough thickness right there to actually put it in. So let's do a real quick call out. Let me just see if I can remove some of this out of our way real fast. All right, well, let's talk about that. Let me get rid of this real quick. Get rid of that. Let's just throw the weld to it, you know. All right, so we'll do the fillet. Here's the fillet first. So we got the fillet, got our size. We'll just keep going with 3/8 just because it works for us. And I can't call an all around, obviously. So what a person would probably do in detailing, you might see it done this way, where they'll call out the flag to imply this side, and then they'll throw another arrow very carefully this way. Notice that I didn't do that. What does that imply that's different? I gotta do some edge prep, which technically wouldn't hurt, but let's just say that I don't want to do edge prep, and I'm gonna do it like that. Okay, so we've got those two covered. Now, this extra flag on top does imply now I'm supposed to be trying to weld up there, but physically you can't. So a person may actually, a detailer may have to turn around and take that back off because of that implication, and they may just do this, if I can hit it right. Or they would just put another fillet weld over here, doesn't matter. But let's just say, well, we're done. So let's just say there's the fillet weld we're going to attach to it, but by golly, we're going to throw some weld to this sucker. So we're going to turn around and add another scenario where, oh, actually, here's something's changed. I got our solution. Someone has, once again, taken some dynamite and taped it to the side of this thing, here, here, and here, for us to weld around. Can't weld the dynamite. There it is, taped right on there. It's got the, you know, the TNT on the side like they're supposed to. There we go. So tape there, tape there. So I can only weld in this zone itself. So what would you suggest? What kind of weld can get me in this area? Slot or plug, all right? Now, what's the difference really between a plug and a slot in all reality? Right, you're basically welding and you're connecting them together. Now, a slot would be better probably than a plug because of the fact that we want to get in right here. So we're going to do a burn through, and how a person might detail this sort of is dependent on a lot of things, but they would probably try to imply that, hey, we're going to do the plug, we're going to do it right here, and they might actually do some hole cutting in the piece, which technically turns it sort of into a fillet weld, but that's the idea. All right, we're getting there. We're getting the concepts down pretty well. So that's the logic we want to go to. You're always thinking about what's a scenario, can I get the welding device into the space that I want it in, and what do I do from there?